We think of the moon as a night traveler, which rises at dusk and is chased from the sky by the morning sun. But the moon is always in motion around the Earth, both night and day. And occasionally the moon moves across the face of the sun. When this happens, we have a solar eclipse. The sun is being observed all over the world every day of the year at many different observatories with many kinds of telescopes. And so it's fair to ask why it is important for astronomers to travel halfway around the world in order to observe a total solar eclipse.
I think I can explain that by pointing out, first of all, that if you observe the sun with an ordinary telescope in bright daylight, you will see or photograph what appears to be a bright ball of gas. And as seen in this way, the sun appears to have a very sharp edge. Well, in reality, it doesn't have a sharp edge. The sun does not terminate at the boundary of the visible disk. It has very faint extensions that go on out into interplanetary space. And this faint outer extension, or corona, as it is called, is very interesting and very exciting because its temperature is very high, about 1 to 2 million degrees, as compared with 6,000 degrees at the visible surface. Well, why can't we observe it in broad daylight? Well, we can't because the very faint corona is just simply lost in the glare of the bright sunlight scattered by the atmosphere. As an analogy, you can picture yourself driving along a very dark road at night and looking out through a dirty windshield. Suddenly, you see a motorcycle coming with a very bright headlight, which is scattered by your dirty windshield, so the whole windshield appears to be lit up. Looks like the sky. And to try to see the corona against the bright sky is just like trying to see the detailed features of the motorcycle rider against the bright windshield of your car. It's just that difficult.
At the time of a solar eclipse, the moon covers the visible portion of the sun, leaving exposed the atmosphere of the sun. First is a thin layer, 10,000 miles thick, called the chromosphere. Extending far above it, 100,000 miles, is a beautiful prominence, sometimes appears. It is only at the time of a total solar eclipse that we see the pearly light, the white corona, extending out 1 million miles from the surface of the sun with a temperature of 1 million degrees.
Finding suitable eclipses is one of the most elusive searches of science. Every eclipse is predictable in its location and duration, but not so predictable where weather is concerned.
Today, we can get above the weather with modern aircraft. And indeed, with jet aircraft, we can follow the eclipse and extend its duration from minutes to an hour.
The June 30th, 1973 eclipse across 1,800 miles of Central Africa qualifies as one of the longest in recent history. Another as long as that won't occur again until the year 2150. The ability to watch an eclipse for more than 7 minutes from the ground, and many times that from a supersonic Concorde racing the shadow across the Earth, then becomes, for the 100 or more scientists who spent many months with National Science Foundation support, a once-in-a-lifetime chance.
This is of use because many of the phenomena on the sun's surface take a duration of an hour instead of a minute or two. For example, the diamond ring effect, which occurs just at the moment of totality. Then there are these remarkable dust clouds which surround the sun, of which we know very little. Perhaps a remnant of the formation of the sun, and indeed a remnant of the formation of the solar system itself.
In his ceaseless efforts to capture the spectacle of the eclipse with his ingenious instruments, man is probing into the most fundamental mysteries of existence. By a better understanding of his star, he will better understand all of the stars and perhaps his own unique position in the grand scheme of the universe.